Hello, everyone, and welcome. I'm Jeong-Sik Chun from Software Platform Lab in the Visual Display business. First of all, I'd like to sincerely thank you for joining this session today. I hope you'd find this session valuable during the next 30 minutes. Now, let's dive into the presentation. Today's top topic is unlocking the future of AI integration. I will be showcasing our effort to achieve seamless AI interoperability in our screen product. I will present three key aspects of AI integration. The first is introducing recognition APIs to transform third-party apps into AI-powered apps. Secondly, I will present a new framework that enables AI to interact with on-screen applications. Third, I will present technology connecting external generative AI services with our screen product. Okay, let's begin. AI screen is continuously evolving. We have been developing AI functions for creating enhanced visual experiences. Additionally, as shown in the picture, we are launching new AI services. We introduced generative wallpaper, allowing you to create images that reflect your preferences using Samsung's generative AI model. And picture quality has been enhanced further to offer a more immersive visual experiences. And we have introduced AI-based sign language avatar to assist the hearing impaired. Samsung is integrating various AI features into its screen product to offer the best screen experiences to customers. And this AI screen is supported by Tizen operating system. Tizen OS offers a wide range of AI APIs for application and services. It also supports AI capabilities across multiple form factors. So, what's next for Tizen OS? The importance of AI integration is rapidly increasing, especially with advancement in large language models. Future applications are set to leverage AI capabilities increasingly more. Tizen OS must be ready to support broader AI integration for these applications. This is our perspective on what comes next and the direction we are heading. We propose three key pillars for the future of AI integration. First, we will expand the number of AI-powered apps. Increasing the number of AI-powered apps will allow users to enjoy a more unique experiences on our screen product. In other words, Tizen OS should support third-party apps to utilize AI on our screens. Second, we need to ensure that apps and AI can interact with each other. It is crucial to ensure that a wide range of apps and features can be seamlessly integrated with generative AI on the screen. Finally, the third pillar is to provide experiences where screen apps can interoperable with external AI. AI isn't limited to the screen. Interoperability with external AI is also essential. All right, then let's explore the first pillar, expanding AI-powered apps. How can Tizen OS enable apps to become AI-powered? One way is by providing apps with screen AI APIs. These AI APIs should efficiently utilize device resources, especially in embedded systems like screen product. We offer various screen AI APIs that can utilize NPU, neural processing unit, on device. This will make the apps more powerful by utilizing AI on screen. However, currently, AI APIs are only available for in-house applications and services. As a result, third-party apps cannot utilize screen AI APIs. To address this, we are now making our widely used recognition APIs available to third-party apps on screen product. Let's take a closer look at the recognition API. Here are the recognition APIs we provide. We are continuously researching and developing ways to enhance users' visual experiences. Our Samsung screens are no longer just devices for displaying images. We have developed face, body, hand detection, pose estimation, and landmark detections. These APIs have been used in various screen services, such as camera AI zoom, exercise analysis in Samsung Health, gesture services, and more. These recognition APIs are on-device, NPU-powered, and now available for third-party apps. They will be released as a web API for public use. You will be able to access the API guide from Tizen developer site. And there's more. The recognition APIs are becoming even more powerful. We now provide information about people or objects appearing on the screen. Multi-object detection, human segmentation APIs will be newly available. The recognition API will continue to be enhanced. We plan to support content understanding in the future. All right, let's move on to the next topic. Now I will present our approach to making Tizen OS LLM friendly. I would like to introduce a new framework that enables apps to work interoperably with AI. One of our goals is to enable interaction between LLM and screen apps, which will increase the use cases of AI on our screen products. When our screen product supports LLM's function calling, the LLM becomes more versatile on our screen. For example, as shown in the picture, when a user asks, "Can you recommend VOD content?" then the recommendation will be displayed on the home screen. This is just one example of the various interactions between apps and AI that should be supported on screen product. Let's dive deeper into this use case. When a user asks, "Please find movies starring Tom Cruise," two functions should be executed on screen. First, only the content that can be played on the screen should be shown. This is due to the various business considerations. So the generative AI services must use the screen's search API to find appropriate content. Secondly, the recommendation result need to be displayed in the media home application on screen. And for this, the recommendation data must be sent to the media home application. To process these user requests on screen, the necessary functions must be triggered by LLM services. This is just one example. Since user requests can vary, it is crucial for Tizen OS to support various interactions between AI and screen apps. Then, what do we need to make this possible? Actually, there is app control in Tizen. App control makes this approach viable. However, there are some issues with this approach. First, the caller needs to know the app ID to control. It would be difficult for generative AI agent to know the IDs of all applications. Second, generative AI agent does not know what kinds of app controls are available. Therefore, there were predefined app control between the caller and the callee. Lastly, APIs can be provided not only by apps, but also by libraries. However, if APIs are not provided by apps, we cannot use the existing app control. As a result, responding to the user's various queries using app control becomes challenging. Therefore, we need a new approach to handle these requirements. Let's check how we can address this. To meet these requirements, we now provide Tizen Actions, a new framework. The Tizen Actions Framework enables interoperability between generative AI agent and screen apps through actions. First, let's start by understanding what an action is. We define action as a specific functional unit for performing function calling on screen. An action can utilize various APIs. Action represent apps' capabilities that can be exposed to the generative AI agent. The app's capabilities are now discoverable through the Actions Framework. The LLM can search for action and execute them in the form of function calling. In this way, the generative AI agent can interact with Tizen application through actions, making it more versatile for screen product. Then the Tizen actions will help transform Tizen into a generative AI-friendly OS. Here is an overview of Tizen Actions Framework. The Tizen Actions Framework provides a set of software components that allows you to register, scan, query, and execute actions. Now let's take a closer look at how these components work. First, action declaration. App developers develop functions they want to expose or declare as actions for existing APIs. You can create a JSON file containing API's information to help LLM understand it. We called it action schema. You then place the action schema in a specific folder to be scanned at an appropriate time. You can also verify using a tool to check if the action is correctly declared. Next, action scanning and building registry. The Actions Framework scans declared actions at an appropriate time and builds an action registry containing all necessary information about the actions. Action registry is updated whenever new actions are installed or existing actions are modified. Querying actions. The generative AI agent can query all actions registered in the system or selectively query specific actions that have similarity to the user's request. Lastly, the action execution. App's actions are executed using Tizen App Control by default. Additionally, some of actions can be declared and executed as plugins, allowing them to run in a more optimized way with performance considerations. Now that we've briefly explored how the Tizen Actions Framework works, let's take a look back at the previous example and see how a user request is handled using actions. Step 1, search app developer registers search action that can be executed by generative AI agent. Similarly, Media Home app developer registers display actions to display recommended content. Step 2, a generative AI agent searches for available actions and executes them. In summary, Tizen Actions Framework facilitates AI interoperability, enabling the generative AI agent to seamlessly interact with multiple apps on screen. And the Tizen Actions Framework enables apps to reveal specific capabilities that can be utilized by generative AI agent. And it allows the generative AI agent to use these capabilities without knowing screen-specific details, such as app IDs. Our vision is to enhance the AI experiences across screen products by utilizing various actions. To achieve this, we have outlined the following roadmap. Phase 1, we will expand available actions and user scenarios. Phase 2, we plan to extend actions to second and third-party apps within the allowed scope. Next, let's move on to the third pillar, where I will explain the interoperability between external generative AI services and our screen product. AI is not limited to the screen. Interoperability with external AI should be also considered. There are various forms of external AI services. In this session, I will discuss connecting generative AI on mobile to screens. For instance, imagine displaying recommended content from mobile directly onto your Samsung TV. By enabling this, we can further enhance the multi-device experience, providing an additional differentiating features. For this, we are excited to introduce Samsung AI Cast. Samsung AI Cast allows users to directly send AI-generated results from mobile devices to our Samsung TV. With this feature, users can easily enjoy images created with generative AI like ChatGPT on a larger screen. And users can create a list of desired content and send it to the TV. Users can find and select it all at once from the home screen. Let's take a look at how it works briefly. The recommended results from the mobile device are sent to the home screen via SmartThings, and the recommendations are shown on Media Home via Multi-Device Experience MDE framework. Here are another use case. You can enjoy AI-generated images from your mobile on our largest screen product using Samsung AI Cast. Okay, let's summarize what we have explored and review our vision for AI integration. We propose 3 key pillars for AI integration on our screen product. First, the Recognition SDK, integrating AI-powered feature into apps. Second, the Tizen Actions Framework, making apps more interoperable with AI. Third, Samsung AI Cast, casting AI-generated content to screens. Through these things, external generative AI service will seamlessly integrate it with screen products. Generative AI agent on screen will be interoperable with screen apps. And apps on screen will become more powerful by integrating AI features through AI API. Our goal is to make screens highly interoperable with AI. AI integration will further enhance the value of a screen product. Thank you very much for being here. This is the end of my presentation.